Hello wonderful viewers, welcome to my channel. Last we did transcription and prokaryotes, and today we are going to continue from where we left the last time. And now we are going to look at consensus sequences in the promoter region of prokaryotes. Now we are going to dive deep into how the promoter would recognize a particular sequence and attach itself to it to unwind it to cause melting to occur in the DNA for transcription to be initiated. Now, a consensus sequence is a short stretch of nucleotide that occur multiple times in a conserved sequence. Okay, so we will look at it very soon in the next slide. But in prokaryotes, we have promoters that the bacteria are prokaryotes. So promoter sequences in bacteria are heterogeneous. It means that they are of varied sizes. They are not the same. And then promoter sequences have certain common features, which makes it possible for the sigma factor to recognize them. And you would get to know those features very soon. These common features are often summarized in the form of a consensus sequence, as I've told you earlier. And in prokaryotes, the promoters are characterized by two hexameric DNA sequences, -35 region and the -10 region. And we will get to know what these -35 and the -10 regions means. And the names were given based on the locations relative to the start site or start point of transcription, which is designated as +1. So in our DNA sequence, we have regions that have the -35, and we have regions that also have the -10, and we have region that is +1, which is the start point of the transcription site. So the start point of every transcription site is closer or at the +1 region. So the -10 site is from 5 prime to 3 prime, which is TAT. This is commonly referred to as the Tata box. Okay, so that is the region that represents the -10, which is from 5 prime to 3 prime. We have TAT, which is commonly known as the Tata box. Okay, and for the -35 sequence or region is from the 5 prime to the 3 prime end. We have TAT, TG, CA, and these are the regions. Okay, so getting from this region down to this side, we are approaching the +1 region. Okay, so from this side, this region and that region, the promoter would recognize and bind to it to cause the DNA to unwind for the initiation of transcription to occur at the +1 site of the DNA or downstream of the promoter. This side is the downstream. From this side coming towards the 3' end here is the downstream, and from this side upwards is the upstream. So downstream of transcription is always below the -10 sequence or -10 region. So the functions of the -35 and -10 sequences, and for the -35 sequence, it provides the signal for recognition by the polymerase, the RNA polymerase. So the -35 region will provide the signal for the RNA polymerase to be able to bind to it, to tell the RNA polymerase that here is the region that you are supposed to bind to cause the unwinding or to cause the melting. And the -10 sequence allows the complex to convert from closed form to open form. If it is in closed form, we cannot have a transcription to occur. But if it is in an open form, transcription will be able to occur. And we have an exclusive AT base pairs at the -10 region sequence, which assists in the initial melting of DNA sequence into single strands. The exclusive AT base pairs, they are also at the -10 region, and we have the AT or TAAT, like those bases would allow or cause, since the bond between A and T is not all that strong, melting or unwinding easily or usually occurs at that region. So this is the region I'm talking about here. So this region, that's the -10. So the TAAT region, that's the exclusive. Exclusive TA base pairs at the -10 region. So in this region, melting occurs or unwinding begins from that side. So due to the TA being, let's say, a lot there, but and the -10 side, as we've told you already, we have the TAAT, and the -35 side or region or sequence, we have TATTGACA. So let's look at the functions again. -35 sequence is to provide the signal for recognition by the RNA polymerase, and the -10 sequence or region allows the complex to convert from closed form to open form for transcription to begin. And let's sum everything up. So the stages of transcriptional initiation. So before it will initiate, we have the holoenzyme. The holoenzyme binds to the DNA sequence and then melting. So when it binds to it, it is in the closed binary complex.